In this video we are going to explain how a machine learning model works. This information is necessary for you to perform the tasks required for our study. If you have never heard of machine learning and models before, don't worry, we are going to introduce the concepts you are going to need later on, when performing the actual tasks. So what is a machine learning model? A machine learning model is a computational model built by looking at historical data, so that a computer can learn how to make a specific set of decisions, in a specific context or domain. Don't worry, you don't need to know the details of how such models are built. You only need to grasp how a model is actually used to make such decisions and a little bit about how it works. You can imagine a machine learning model to be a sort of magic black box which receives some data as an input and produces an answer as an output. Let's take a look at a specific example. Now imagine that you work in a bank and somebody built a machine learning model to automatically decide which credit card applications from your customers should be declined, and which should be approved. Using the same diagram we have shown you before, you can now see that for this specific example, the machine learning model receives information about each application as an input, and it provides, for each application, a suggestion on whether the application should be approved or declined. Before we move on, it is important to clarify an important aspect about how a machine learning model makes such decisions. Each application in the credit card example is described by a number of predefined characteristics which we call features. Such features are used by the machine learning model to assign a specific suggestion, which we call a label. Still, we use the credit card application as an example. Here, each application is described by the features you see in this table, for example, credit history, and months since last delinquency. Here the model assigns to each application one of the two possible labels, either approve or decline. For the purpose of this study, you should then think of a machine learning model as an automatic procedure that takes as an input a specific set of objects and, by looking at the values of these objects, assigns to each one a specific label. Now that you have learned what a machine learning model can do and the concept of features and labels, it's time for us to provide more information about how a machine learning model makes such decisions. One way to describe this process is through the use of a set of rules. Using the credit card application example again. The way the machine learning model makes the decisions can be described by the set of rules that you see here. Basically, all the visual representations we are going to use consist of three parts. First, median values for each feature, on the top. Second, rules. Third, legend area, where we explain the meaning of all the symbols and colors we use in the visualization. Please keep in mind, the median values here are useful in the later tasks. If you are not familiar with median, don't worry, just think of it as a kind of average value. Generally, we think a feature value is high if it is larger than the median of this feature. And if a feature of an application has a value smaller than median, we think this application has a low value of this feature. In this diagram, we have four rules, R1, R2, R3, and R4. Each line is a rule. And when an application comes, if its credit card is larger than 72, and months since last delinquency is larger than 12, then it matches rule R1, which suggests accept. As demonstrated, the color of each circle represents different labels, or suggestions in this credit card example. In the later study, you will need to match a feature value with a rule. For example, given credit history equals to 27, what rules can match this condition? To perform this task, you will need to identify rules using the given feature first. In this case, we identify rule R1, R2, and R4 that contain the feature credit history. Then we need to check whether the given feature value, 27, can meet the rule condition. And because 27 can only meet the condition that credit history is smaller than 57, we report rule R4. And to match a range with rule, the steps are similar. For instance, we want to find rules that a high value of credit history may match. Now we have to determine the high value range for credit history first. From the median information on the top, we can know that high value here means values larger than 76. Then we identify rules using the given feature, credit history in this case. So still rule R1, R2, and R4. In the end, we need to check whether the range, larger than 76 overlaps any rule range of this feature. Here we identify that credit history larger than 72 in Rule R1, and credit history larger than 57 in Rule R2 can meet the condition. For the same set of rules R1, R2, R3 and R4, we can also present them in this way. In this table, each row is a rule, and each column represents a feature. For each rule in a row, the condition is placed at a specific column according to the feature it uses. Similarly, if an application has a value of credit card larger than 72, and months since last delinquency is larger than 12, then it matches rule R1, which suggests accept. Keep in mind, a useful way of reading a rule is that a square on the right side always means the feature of this column is larger than the given value, and a square on the left means that this feature is smaller than the given value. In this tabular view, we can look at a specific column, and find out the rules that contain this feature. For example, if we are only interested in the feature trades with balance, we can locate the column of trades with balance first. Then we can focus on rule R2 for further exploration. On the top of this table, we can also find out that the median for trades with balance is 3. For this set of rules, what should we do to match a feature value with a rule? We still use credit history equals to 27 as an example. Here, with the tabular view, we can locate the given feature, credit history, first. Then we can identify all the rows that contain content in this column. In the end, we only need to compare 27 with all the conditions stated in the cells. After match a feature value with a rule, how about matching a range with rules using the table? For instance, how to match rules that a high value of credit history may match. Similarly, we have to locate the given feature first. Then we can find out the rules that contain this feature and its median, which is helpful to determine the high value range. In the end, we check whether the high value range larger than 76 can overlap any feature range. Here we can find out that credit history larger than 72 in rule R1, and credit history larger than 57 in rule R2 can meet the condition. Now we introduce the last visual representation we are going to use in this study. Similar to the previous one, we still place a condition at specific column based on the feature this condition uses. However, here we use a black rectangle marked with values to represent the condition. If the rectangle is marked with two values, x and y, then it represents a range larger than x and smaller than y. And if the rectangle only has one value, x, marked on the left side, then it represents a range larger than x. For the rectangle with only value x marked on the right side, it means a range smaller than x. And a line with a dot on it marks the position of the median value of a feature. The median values are still presented on the top of the table. Here in this table, the third row represents the rule R3, if months since last delinquency is smaller than 65, then suggests decline. In this visual representation, the horizontal line in each cell can be seen as a part of the axis for a feature. For cells in the same column, numbers on the left are always smaller than those on the right. For example, if we compare some numbers that appear in the second column, 12 is on the leftmost position among them because it is the smallest one. So how do we match a feature value with a rule if we use this representation? We can still follow what we did with a tabular view. First we locate the given feature, months since last delinquency, at the second column. Second, we find that all rules R1, R2, R3 and R4 are using this feature. In the end, we compare the given feature value, 67, with all the feature ranges. To do the comparison, actually we can imagine the position of the given value based on other number positions. Then we just check whether this value position can be covered by any black rectangles. In our case here, we locate 67 on the axis first. We may not know the exact position, but at least we know that it should be close to the median value 66, and on the right-hand side of 66. Then we can virtually draw a vertical line across the ranges in this column from the location of 67. Then we found that this line can across the first and the fourth row. So we know that the first and the fourth range contain this value. And to match a feature range with a rule, we can also do the comparison and match visually. For example, we want to match the high value of the feature months since last delinquency with rules. Follow the steps we introduced for a tabular view. We can locate the feature months since last delinquency first. Then we can identify rules we want to test and the median value of this feature. Now we know that median is 66, because the high value range should be the range on the right-hand side of 66, it should look like the purple rectangle shown here. Then we just check what rule ranges overlap with this purple rectangle. As shown here, we identify the overlapping parts in Rule R1, R2, and R4. Before we move on, it is important to highlight a couple of things about how the rules work. In practice, an application may match multiple rules or cannot match any rules. And then other metrics will be considered. But in this study, you only need to report the rules that match the given description in most cases. If a model suggestion should be reported based on the rules it matches, we will give you more instructions. Now that we have explained all the concepts necessary for our study, it's time for us to verify that you have learned them before we can move on to the next steps. As soon as this video ends, please click on the Start Verification button to access the verification test. If you pass the test, we are going to introduce the tasks we need you to perform.